Welcome back. This is section 1.2, installing the toolchain. In this short video, you will install the 3 tools you need to write C and check that they all work together. You have an idea for a program, but your computer does not understand C yet. Let's fix that. A broken setup means 0 programs. A working setup lets you write, compile, and run C for the rest of this book. Here is the plan for this video. First, we cover the 3 tools you need to write C: a text editor, a terminal, and a compiler. Next, we install the compiler. You will see the steps for Linux, for Mac OS, and for Windows using MSYS2. Then we look at the path. This is how your shell finds the gcc command, and it explains why you sometimes see the error, command not found. Finally, we run a smoke test. This is one quick check that your toolchain really works before you start writing programs. Writing C needs 3 tools working together. This picture shows them in a row. First, a text editor. This is where you write your .c source files. Second, a terminal. This is where you type commands. Third, a compiler. This is the program that turns your source code into machine code. Together, these 3 tools are your toolchain. A text editor is where you spend most of your time. It must save files as plain text. That means no fonts, no formatting, and no hidden data. Word processors like Microsoft Word or Google Docs add hidden formatting the compiler cannot read. You need a program made for code instead. Let's look at some good editors for beginners. VS Code runs on Windows, Mac OS, and Linux. It is free and has a C extension. Sublime Text is fast and light. Nano is already installed on Linux and Mac OS, and it runs right inside the terminal. Notepad++ is a free, simple choice on Windows. If you are not sure, VS Code is a safe default. The exact editor does not matter much. What matters is plaintext.c files. The terminal is your command center. Every time you compile or run a C program, you type a command here. Open your terminal now. You should see a prompt waiting for you. Type echo space quote terminal works quote and press enter. If you see terminal works printed back, your terminal is ready. The compiler is the key tool. It reads your .c file and produces machine code. The 2 most common C compilers are GCC and Clang. GCC is the standard compiler on Linux. Clang is the default on Mac OS. Both take the same basic commands, so you can use GCC or Clang, whichever you have. Let's install the compiler. On Linux, Debian, or Ubuntu, type sudo apt update and then sudo apt install build essential. The build essential package installs GCC and the standard library headers. That is everything you need to compile C. The word sudo runs the command with administrator rights. On Mac OS, type xcode-select space -- install. A dialog box appears. Click Install. This installs Clang, which answers to both the Clang and the GCC command. On Windows, download MSYS2 from the MSYS2 website. Run the installer with the default settings. Then open the MSYS2 UCRT64 terminal and run the pacman command shown on the slide. It installs GCC inside MSYS2. On any system, check the install by typing GCC space -- version. You should see the compiler's name and version number. If you see command not found instead, The compiler is either missing or not on your path. The next slide explains that. When you type GCC, your system must find the real compiler program on the disk. It does not search every folder. That would be too slow. Instead, it searches a fixed list of folders stored in a variable called path. You can see your path by typing echo space $path. Each folder in the list is separated by a colon. On Windows, the MSYS2 shell used in this course separates folders with a colon too, while native Windows uses a semicolon. When you type GCC, the system checks each folder in order. If none has a match, you get command not found. Imagine you installed GCC, but GCC version prints bash :gcc : command not found. Does this mean GCC is not installed? Not always. It could be installed but not on your path. Both cases show the same message. To investigate, run with GCC on Linux or Mac OS. It searches the folders on your path. If GCC is on your path, it prints the full path. If it prints nothing, GCC is not on your path. Nothing printed means GCC is either not installed or installed in a folder that is not on your path. If you know where GCC lives, add that folder for this session with the export command shown. To make it permanent, add the same line to your shell config file, .bashrc or .zshrc. You now have all three tools. Let's check they work together with one command. It creates a tiny C program, compiles it, runs it, and reports success. The first part, echo, writes a tiny valid C program into a file called test.c. The second part, gcc, test.c-o test, compiles it into a program called test. The third part, ./test, runs that program. The last part prints, Toolchain works, but only if everything before it worked. The in between commands means only run the next command if the one before it succeeded. If compiling fails, the rest stops, and you do not see the success message. A common mistake now. You install GCC or think you did, then type GCC version and see command not found. There are three possible causes. Maybe it did not install, so run the install again and watch for errors. Maybe it installed in a folder not on your path. Or maybe you opened a new terminal before your shell config loaded the new path. To fix it, first find the compiler with the find command. If it exists, add its folder to path. If not, install it again. One more common mistake. You save hello.c on your desktop, then open a terminal which starts in your home folder and type gcc hello.c-o hello. The compiler says hello.c, no such file or directory. The problem is simple. The compiler looks in the terminal's current folder, not where your editor saved the file. The fix: move into the right folder first with the cd command or use the full path. Better still, keep one project folder and always save and compile there. Let's recap. Your C Toolchain has three tools: a text editor to write .c files, a terminal to type commands, and a compiler to turn source code into machine code. First point, path tells your system where to find programs like GCC. Second point, command not found can mean the tool is not installed, or that it is installed but not on path. Third point, a smoke test checks that all three tools work together. Next, you will write, compile, and run your first complete C program, and understand every line of it.